Okay, let's dive into a real problem. Let's say you are given a list of numbers. Let's say L is some list with numbers. Let's say we define list by these square brackets. Let's say the list contains 23. Let's say that's a value minus 4. That's a value 0. That's a value 73. That's a value, and maybe minus 10. That's a value. Maybe 13. That's a value. So let's just take an example that we have 1, 2, 3, 4, 5, 6 values in a list. So and the list is basically, we took the list here as L, and we just described that. Let's say the list is declared by or expressed by these square brackets, and the elements of the list, they are separated by comma. That is just our convention for this kind of problem, for this problem, just for this code. And I'm not talking about any particular programming language yet. This is just a list of numbers. And let's say we want a procedure that finds out the minimum value of any list. Well, first of all, why this problem has multiple instances? Well, we need to come up with a solution that works for any list. For example, if the list has these 6 values, then the procedure should find out the minimum value in this list. The minimum value in this list out of all the values is minus 10, because minus 10 is smaller than every other value. 23 is bigger, minus 4 is smaller than 23. 0 is bigger than minus 4 because the value with the negative sign, it is smaller with the value of a positive sign. But if you have two values with negative signs, the value with a bigger number in terms of magnitude is actually smaller in negative sense. So if you compare minus 4 and minus 10 is smaller in minus domain. In positive domain, the result is different. So I was talking about why this problem has multiple instances, why you need a general solution for that. That's a list. Just go and find out the minimum. That is minus 10. Go home happy. Well, we need a solution that works for another list with different numbers, and maybe different number of numbers. Maybe in this list we have 6 numbers. Another list may have 74 numbers. Another list may have 1 trillion numbers. We want to come up with a procedure that always finds out the minimum value in that list. Obviously, the minimum value may repeat. The minimum value may occur more than once in a list. So what is a minimum value? Rather than knowing how many times it occurs, what is a minimum value? That's a problem, finding out a minimum value. And we want to come up with a procedure that finds out the minimum value regardless of the list. Whatever the list is, this procedure should actually return or end up finding out the minimum value. So in this particular case, again, for this particular example, the minimum value is minus 10. And we will take an example of this list and we will see how to code a procedure for that. So, but before starting this procedure, what kind of things we really need to write a pseudocode for this kind of problem? We may start by writing that program, like in the previous video, program name as search, and then we take input list, then we take input the number of values in the list, the total number of values, and then we move on as we want to move on. But writing out a procedure in terms of pseudocode, it is always good to avoid these input statements inside the pseudocode, and always supply whatever needed. Always supply the instance from outside and assume that the instance is supplied, and then just work on that instance. Rather than reading the instance, rather than taking the values of a particular instance from inside the code, it is always a good practice to supply the instance from outside. So supply the list from somewhere, and this n is really the size of the list. In this particular case, let's say if this is the list, then that list will be there. supplied from somewhere. We will see how to supply that. And this n value here, in this particular case, the n value is 6, the total number of values in the list: 1, 2, 3, 4, 5, and 6. These are 6 values. So it is a good practice to, rather than writing program and then this, just write the name of the problem you are going to solve. In this particular case, the name is search minimum from list. And then this particular, we are talking about this list L with total number of elements as n. Whatever the values inside the L is, we do not know. And this n may take a different value. This L can be different, this n can be different for different instances. But it is not a good practice to take input from inside here. Then one more convention is that, let's say list of 2 represents the second element in the list. In this particular case, L of 2 is basically the second element in the list, which is -4. L of, let's say, 3 is the third element in this list, which is 0, and so on. So let's take a convention that whenever we want to access the elements of the lists, whenever we want to read the elements from the list, we will read the element number by giving the element number here. Let's say if we write L of I, that means it means the ith element of the list. So first we take a variable. We are assuming here that the list is supplied to us, the total number of elements in the list is supplied to us. So we first take the minimum value, which we really want to compute, the minimum value we want to compute. But any list can be supplied in this procedure. So what's the procedure? The minimum value that we want to compute, we just consider the very first value of the list. In this case, the very first value is 23. We consider that is the minimum value. Obviously, that is wrong. This is not minimum value. Minimum value may be somewhere else. Or maybe this one may be somewhere else, but we are not sure that the first value in the list is the minimum value. But let's just hold on for a moment and move on. Let's say the minimum value is this. Here, this is called the assignment. This min value is a placeholder or a variable, and I have assigned this value L1 to it. Now, from here onwards, the min value will be having a value which is 23 in this particular case. Okay, so min value is this, which is 23 now. Let's declare another variable which is called counter. We may need this counter, and let's declare this with 2. Why we are declaring this with 2? It will become clear later on. So now so min value right now for this particular list, the min value takes the value 23. So, and counter takes the value 2. These are 2 things for these 2 variables. Now we apply a loop while counter is smaller than n, smaller or equal to n. Remember, the value of n for this particular example is 6, and counter here is 2. So because counter has value 2, while 2 is less or equal to 6. First check whether this condition is true or false, because if this condition is true, then you will go to the body of the loop. Then this whole box will execute. If this condition becomes false, then you will exit the loop and will go out. So now counter is 2, so 2 is smaller or equal to 6. True, false? That is true. So the condition is true. 2 is indeed smaller than or equal to 6. That is true. So we will go inside to the box and see what happens. Then what we will do, we will pick a value from at the index counter. Right now the counter has value 2. L of counter means pick the value, because the counter has value 2, pick the second value, which is -4, and pick that value -4 from the list. Pick that value and copy that value or assign that value to a variable v. That's a new variable v, maybe needed somewhere. Okay, Previously, the min value, which is a variable, it was containing the very first value, which is 23. Now we have picked the second value, the counter value is 2. So we have picked the second value from the list, which is -4. Now we compare if the value now, which is -4, is that value smaller than our minimum value so far? The minimum value so far is 23. So -4 is smaller than 23. Yes, the condition is true. If the condition is true, we will go into this block. Otherwise, we will go into this block. So right now the condition is true. So we will go in this block, and minimum value will just be replaced by the new value. And the new value right now is -4. So because -4 is smaller than 23, so we are here in this body. The if condition becomes true. We are in this body, and the minimum value becomes whatever the value is in V. And right, for this example, the value in V is -4. Okay, so if you go into the if condition, then you're not going into the else part. Either you're going to if part or in the else part, one of them. Okay, so then we move back. Oh, there's a bug here. We need to add the counter. We need to increment the counter here. After this, before this, there is another statement, increment the counter. Increment counter. That's another statement, increment counter. So now increment the counter after this if part, increment the counter, and the counter will become 3. Now we will repeat the procedure and check 3 is smaller than 6. Yes, we will go inside and we will pick, now the counter value is 3. We will go and pick the third entry, and now the third entry will be in V. The V will now contain 0. Previously it contained -4, now it will contain 0. Min value is containing -4 now. So 0 is smaller than -4? No. If 0 is smaller than -4, then do this. But 0 is not smaller than -4. Then go to the else part. And else part is just saying, just go on, do nothing. I mean, don't do anything. So when you're here, don't do anything, exit if condition, increment the counter again. Now you increment the counter value will become 4, and the value at 4 is 73. First of all, check 4 is smaller or equal to 6. Yes, V will contain the value at index 4, which is 73. 73 is smaller than -4. No, do nothing, increment the counter, check the while condition. Now counter will be 5. 5 is smaller or equal to 6. Yes, pick the fifth entry because counter is fifth. The fifth entry is -10. -10 is smaller than -4. Yes, okay. Replace min value with the new value. Now the min value will contain -10. Okay, because if has executed, else will not execute. You exit the if condition and then you increment the counter. The counter will become 6. Now 6 is smaller or equal to 6? Yes, because 6 is equal to 6, hence the condition is true. Now you go and pick the sixth entry, which is 13. Check 13 is smaller than -10 because min value is containing -10 so far. No, that is false. Go to else condition, go to else part, just go on, do nothing, increment the counter. Now the counter will become 7. And you go back and check the condition. 7 is smaller or equal to 6? False. Exit the loop. Okay, exit the loop, go to this condition, go to this statement now. Now you're out of the loop and return the min value. And see, the min value here is containing the actual min value, which is -10. So that's how we search the minimum. This return is also a keyword. So which means if we just use that function, if we just use that pseudocode with if we just use that pseudocode for this different kind of lists with its sizes, whatever the list, this was just one example. If we change the list, the procedure will work. One bug in the code was the increment counter statement was not there. It should be there after this end if and before this end while here. So that was a pseudocode of searching minimum. In the next video, we are going to use this pseudocode and we will see how to rearrange the values of a list or sort the values of a list such that all the values that are smaller, they become earlier than the bigger values, and the problem is called sorting. So in the next video we are going to talk about one more problem, very famous problem called the sorting problem. And after that problem we will be going towards Python, because after that problem you'll be having a fairly good idea how to solve a problem, how to write a pseudocode for a problem. And the way we are writing the pseudocode is very close to the actual Python code, which will become so clear to you. So hope to see you in the next video.